This video is the science behind long jump. Long jump is an athletic field event that consists of a short sprint to a jump. The long jump consists of 4 stages: the run-up, take-off, flight and land. The objective of long jump is the athlete attempts to get their feet as far forward as possible without falling backwards and landing to obtain the best jump. The centre of gravity is an imaginary point in a body of matter where, convenient in certain calculations, the total weight of the body may be thought to be concentrated. For example, when we run, our centre of gravity is in our hips. The approach phase is vital for setting up the success of the overall jump. The purpose of the approach phase is to develop an optimal horizontal velocity and adjust the body into a position that will be beneficial in the takeoff phase and allow the takeoff foot to be accurately placed on a board without fouling. Fouling is when your foot goes beyond the designated takeoff area. During the approach phase, Newton's first and third law of inertia. This is when a body will remain at rest or travel at a constant speed unless acted on by an external force. For example, if a person was in a car without a seatbelt and brakes suddenly, they would be thrown forward as they would have stayed at the same speed the car was at before it stopped. An action-reaction. For every action there is an equal and opposite reaction. For example, a student pulls on a desk, the desk pulls on a student. This is how you can pull yourself forward. These are represented as the athlete approaches the winning board. The athlete starts to sprint towards the board to take the jump. As the athlete's feet meet the ground, it produces a downward and backward motion, therefore exerting a force in that direction. The athlete also exhibits Newton's first law of motion. Here, the athlete's forward and upward motion will continue its acceleration as long as there is a force exerted upon it. The forward and upward motion produced when the athlete continues in a linear motion towards the same pitch creates speed. But with great speed must also come great force. As the athlete reaches the board, they will be at their fastest control speed. By this point, they will be preparing for their takeoff. The athlete's centre of gravity will change to a lower state to improve the success of the takeoff phase. When the athlete does take off, the pressure on the leg at the time of takeoff is approximately 10 times the body weight of the athlete. Newton's third law, action-reaction, notes that objects exert equal but opposite forces on each other. When a long jumper pushes down on the ground during their takeoff, the earth pushes back on them in the opposite direction with the same size force at exactly the same time, and as a result the athlete moves in the opposite direction. This force is called the ground reaction force. The ground reaction force tends to change the speed and direction of the athlete's centre of mass. An athlete's vertical takeoff velocity is produced by the vertical ground reaction force exerted on the athlete and initially acts to reverse the athlete's downward velocity at takeoff, therefore accelerating them upwards. We also have to look at Newton's second law of motion. Force is proportional rate of change in a body's momentum. For example, pushing an empty shopping cart is easier than pushing a loaded shopping cart. This is because of the relation between the mass of the object, the force applied to it, and the acceleration produced. Since mass has an inverse relationship with acceleration, the loaded cart tends to move at a slower pace than the empty cart. One way we can use this to our advantage is if we increase our time of impact, we can increase our momentum. So this means the longer the impact is on the board, the more momentum in the jump. If we put this all together, a fast controlled run-up, a powerful takeoff, and maximum time spent on the board, we will achieve some optimum jump. Thanks for listening and good luck in your future long jump careers.